everyone, and we have started the sessions to give you clarity about the network theory. So in today's session we are going to discuss about superposition theorem. Without wasting any time, first of all we have to know about what is superposition theorem. Then the superposition theorem principle states that the response in a linear network, having more than two independent sources can be obtained by adding the responses caused by each independent source acting alone. Okay, but while doing this, when one independent source is acting, the other independent sources, voltage source is getting short circuited and current source is open circuited. Okay, but note, do not touch dependent sources. Okay, now the next point in this category, a superposition theorem is applicable only to the linear networks. And what is linear networks? A linear networks always satisfy two principles. One is known as homogeneity principle, and second one is known as additivity principle. Okay, so if we discuss first what is homogeneity principle. Homogeneity principle is what is the meaning of homogeneity principle? In a network, if a network having only one independent source, and now if we are scaling the source by a factor k, then all the voltages and current or power will also be scaled by some amount of value. Now what we are going to discuss here is that if we are scaling the source, whether it is voltage or current source, by a factor k, then all the responses in the network present will be scaled. Like if a current response, then the new value of current will be equal to k times of old value of I. Similarly, V new is equal to k times of V old. Similarly, power new is equal to k square times of what? P old. Why it is k square? Because power is a function of I square or V square. That's why it's a k square. Okay, let's see what I want to say here. Let's take a network having only one, but the restriction is what? There must be only one independent source. If there are two independent sources, then you cannot apply instantly in that homogeneity principle. Okay, but we know that in superposition principle, at a time only one independent source will act and other independent sources will be deactivated. So let's take a network. Let us assume this is 16 volt, this one is 2 ohm, this one is 4 ohm, this one is 2, and this one is again 2. Okay, now if you want to find I1, I3 and I2, you can easily find all these values. You will get I1 is equal to 4 ampere, I2 is equal to 2 ampere, and I3 is equal to 2 ampere. Okay, now see, now I'm going to change the value of this Vs. Let's take the new value of Vs, Vs is equal to now 32 volt. What does it mean? It means that it has been scaled by a factor k is equal to 2. How? 16 multiplied by 2 is equal to what? 32. Now all the responses what you have calculated, I1, I2, I3. If you want to calculate this V1, you can calculate how much you will get. V1 is equal to 2 into I1. I1 is 4, that is equal to 8 volt. Similarly, you can calculate this voltage, and this voltage. So all the responses will be scaled by that factor except the power value. Power will be scaled by k square factor of the old value. So the new values of I1, I2, if I want to calculate I1 new, will be k times of I1, that is equal to 2 times of 4, that is equal to 8 ampere. Similarly, I2 new is equal to 2 into k, that is equal to 2 into 2, that is equal to 4 ampere. Similarly, you can get I3. Similarly, you can get V1 new. What is the new value? That is equal to 8 times of k, that is equal to how much? That is equal to 8 into 2, that is equal to 16 volt. If you want to calculate the power in this, then power, initially what was the power? I square into R, that is equal to I square is 4 square, that is 16 into what? 2, 32 watt. Now the new value will be 32 watt into k square. K is how much? That is 2. This is the meaning of scale. So don't get confused with this homogeneity principle. Now the next one is, what is the next one? That is the additivity principle. What is the additivity principle? Next one is number 2 is additivity principle. The additivity principle means what we have written here. This is the additivity principle, that the response in a linear network having more than 2 independent sources can be obtained by adding the individual responses caused by each independent source. While doing so, all the other independent voltage sources will be short circuited and current sources will be open circuited. Is it okay? This is what the additivity principle explains. So if I want to explain some good things in the additivity principle, so I can say that in any network, the response across an element will be the function of the each sources present in the network. Why so? At a time you are applying a one source, the next time you will apply next source, you will get some different response. The next time you will apply third source, you will get some different response. So we can say that the total response across an element, let's assume it, that is equal to Vx, is the voltage across some element. That will be a function of, let's assume there are 3 sources are present, 2 voltage sources and 1 current source, independent sources. Then what will be the response? That will be a function of some amount of K1, that is function of first voltage independent source, plus K2 second voltage source, K3 one independent current source present in the network. Similarly, dash and so on. Similarly, if I want to calculate Ix, this will be also can be written in the same manner: K1 V1, K2 V2, some K3 I1. These K1, K2, K3, K are different values for Ix and Vx. So in any network, we can say that in a linear network comprises of n number of independent sources, the response across a particular element can be represented as Vx is equal to K1 V1 plus K2 V2 plus K3 I1 plus dash 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 Kn Vn. Similarly, Ix can also be written as K1 V1 K2 V2 K3 I1 plus dash 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 for Kn, whatever the next source is, Vs. Okay, so what is the basic point in this equation? That is, these V1 V2 I1, everything is what? That is the independent sources. Independent sources. Similarly, K1, K2, K3 all are constants. That depends only on the network structure. This is what is the basic idea for superposition principle. Now if you want to see how to apply all these things in superposition principle, then you have to do some problems. Okay, so I'm starting with the first problem in this category. That is a very nice problem. It's a ESE problem. See how I am going to apply all these things. First things, it is given that there is a linear network. It's a resistive network. It's a resistive network. There is a current source. This is Vx. It has been given to you. Next one, that is what? V1. It is given if V1 is equal to 8 volt, I1 is equal to 12 ampere, then Vx is equal to 80 volt. It is given to us. Similarly, if V1 is equal to minus 8 volt and I1 is equal to 4 ampere, then Vx is given as 0 volt. Similarly, if V1 is equal to 10 volt and I1 is equal to 10 ampere, then it is asking what is the value of Vx. These data has been given to us, and according to this data, what is the value of Vx. So we know in this is a resistive network. This is a resistive network. We have two independent sources. We have to calculate the response across Vx. So we know that to get a response across any element, what we will do? We will apply additivity principle. So Vx can be written as, Vx will definitely the function of V1 or and I1. So we can write it. It will be K1 V1 plus some K2 I1. I don't know about K1 and K2 values. We can calculate according to the given data. So if we apply this one, first one, what we will get? Vx is equal to 80 volt. Then V1 values are 8. K2. Then I1 is equal to how much? 12 ampere. This is first expression. Similarly, if V1 is equal to Vx is equal to 0 volt, then again applying this equation, K1, V1 is minus 8 plus I1 is how much? That is 4 ampere. Now solving these two equations, we will get K1 is equal to how much we will get? We will get K1 and K2 values, that is 2.5, and K2 will be 5. Okay, now we know the constant values K1 and K2. Now we have to calculate if V1 is equal to 10 volt and I1 is equal to 10 ampere, then the value of Vx. Just apply this equation. Vx is equal to K1 is how much we have got? 2.5 into 10 plus 5 into how much? 10 ampere. You will get Vx is equal to how much? 75 volt. So this is the right answer. So in this way you have to approach. In this way you have to approach for network. Similarly, coming to the next problem. What is the next problem? That is, in the given network, the network is given like this. In the given network, this is a resistive network. This is Vx. This is some resistance R, and the power is given as Vx. This is a source plus minus Vs, and here it is given as Ix. It is given that if Vs is equal to 10 volt, then Ix is equal to 6 ampere, Vx is equal to 4 volt, and Px is equal to 5 volt. Now it is asking if Vs is equal to 25 volt, then Ix, Vx and Px will be. So we know that there is a single independent source present in the network, and what we are getting, if Vs is 10 volt, Ix, Vx and Px responses are given to us. Now what he is doing here, if Vs has been changed to 25 volt, I have already told you, if the independent source is in a network, if there is only single independent source and that has been scaled by some factor, then the responses will also be scaled. So this is Vs new value is 25 volt, old value is 10 value. How much it has been scaled? The K value you can calculate how much it will be. 225 divided by old value 10, that is equal to 2.5. Then Ix new is equal to how much? K times of Ix old, that is 6, that is equal to 2.5 into 6. Is it okay? That is how much? 15 ampere. Similarly, Vx new is equal to K times of Px old is 4, that is equal to 2.4 into 4, that is equal to how much? That is 10. Similarly, Px new is equal to 2.5 square into 4, that is equal to 31.25 watt. Is it okay? This is how you will do by using superposition principle such type of networks. I'm not going to tell the networks like there is some independent sources are there. These are the complications you will face in the exam, and these videos are strictly related to the to understand the concepts, how to apply and how to deal with all this. This is a very basic tutorial what I have given today. In the next lecture we will move forward for some standard and good problems. Okay, so subscribe to this channel and share to others, and for doubt solving just join the No Problem Facebook group. Thank you very much.